Okay, good afternoon. I was expecting a bigger turnout because of the point for the course evaluation. So anybody who's in webland watching in real time, time to get up, out of bed, get dressed, hustle over here, fill out a course evaluation. Okay. Good internet conference, MT3 solutions online, all that administrative stuff over there. You can read. Today we're talking about the analyzing evaluator. And okay, stop playing with the Mobius strip, you guys. Pay attention. The analyzing evaluator is a variant on the metacircular evaluator. And basically, what it is a compiler for scheme programs. But instead of compiling scheme programs into machine language, it compiles scheme into scheme, which will seem a little weird, but you'll see that it actually is useful. So on the board here is the factorial function that you know and love. And up on the screen is MC eval, the eval part of the metacircular evaluator. And I would like you to imagine that you are the scheme interpreter and somebody calls fact 5. So what do you have to do? You look at that expression and you say, is it self-evaluating? No. Variable? No. Quoted? No. Assignment? No. Definition? No. If? No. Lambda? No. Begin? No. Cond? No. Is it an application? Is it a procedure call, in other words? Why, yes, it is. That is to say, it's a list that isn't a special form. So we call MC apply after making an environment in which num is bound to 5. And in MC apply, it calls MC eval on the body of the procedure. The body of the procedure is what's up on the board there. It's the if. So let's come back up and see how we evaluate that if expression. Is it self-evaluating? No. Is it a variable? No. Is it quoted? No. Is it an assignment? No. Is it a definition? No. Is it an if? Yes, it is. Cool. So we go to eval if. Eval if basically says, first evaluate the first argument, which is the equal num 0. So we're looking at equal num 0, and we say, is it self-evaluating? No. Is it a variable? No. Is it quoted? No. Is it an assignment? No. Definition? No. If? No. Lambda? No. Begin? No. Cond? No. Application? Yes, it is. So this time we're calling a primitive, and I'm skipping a lot of steps about evaluating sub-expressions and everything. I'm just trying to hit the high points here. So we have to evaluate equal sign. Equal sign is pretty easy to evaluate. Is it self-evaluating? No. Is it a variable? Yes. So we look up its value, and it turns out to be the numeric equality testing procedure. Then we look for num, and we say, is it self-evaluating? No. Is it a variable? Yes. We look it up. Its value is 5. And then we have 0. And we say, is that self-evaluating? Oh, yes, it is. So its value is 0. So now we can call equal with the arguments 5 and 0. Are those equal? No, they're not. So we get the value false. So we say, look at that, and we say, is it true or false? It's not true. So we skip over that 1, and we go to the bottom line, the one that starts times num. And we say, is it self-evaluating? No. Variable? No. Quoted? No. Assignment? No. Definition? No. If? No. Lambda? No. Begin? No. Cond? No. Application? Yes. So now we have to evaluate the sub-expressions. Well, let's evaluate that asterisk. Is it self-evaluating? No. Is it a variable? Yes. So we look it up. Its value is the multiplication procedure. How about num? Is it self-evaluating? No. Is it a variable? Yes. So we look it up. Its value is 5. Now how about that next thing? The parenthesis, fact, etc. Is it self-evaluating? No. Variable? No. Quoted? No. Assignment? No. Definition? No. If? No. Lambda? No. Begin? No. Cond? No. Application, yes. It's an application. So we have to evaluate its sub-expressions, and then we can evaluate its body in a new environment. So let's evaluate fact. Is it self-evaluating? No. Is it a variable? Yes. So we look it up. It's the factorial procedure. And now we have to evaluate minus num1. Self-evaluating? No. Variable? No. Quoted? Blah, 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 blah. Application? Yes. So we have to evaluate minus num1. We evaluate the pieces of that. Minus sign. Self-evaluating? No. Variable? Yes. So we look it up. It's the subtraction procedure. Now we have to evaluate num. Self-evaluating? No. Variable? Yes. So we look it up, and it's 4. How about 1? Is it self-evaluating? Yes. So its value is 1. So now we call minus with the argument values 5 and 1. It gives us the answer 4. So now we're calling the factorial procedure with an argument of 4. So we call MC apply with the procedure and a list containing 4. Apply makes a new environment with num bound to 4. And then it says, evaluate the body of the factorial procedure, which is that if. Is it self-evaluating? No. Variable? No. Quoted? No. Assignment? No. Definition? No. If? Yes. So eval if. We have to eval equal num 0. Are you bored yet? Yeah. I am. So the point is, by the time we actually get down to factorial of 0, and that's equal to 1, and then factorial of 1 equal to 2, and so on, by the time we actually figure that all out, we have looked at this if statement 5 times, right? 6 times, from 5 to 0. And each time through, we say, well, that first argument, that's a procedure call. Second argument is self-evaluating. The third argument is a procedure call. Now, within those procedure calls, there's a variable lookup and a variable lookup, and then there's a procedure call and another procedure call. We sort of figure out the shape of this expression, the pieces of the expression, 6 times. And each time it involves going through this big, long cond with a bazillion clauses, checking each time to see if this thing is self-evaluating, and is it a variable, and is it a quote, and so on. So we would like to avoid that. And the way we'd like to avoid it is what we'd really like is to evaluate the body of a procedure only once, instead of every time you call the procedure. We can't quite do that, because how we evaluate it depends on the value of num. So if num is 0, then we have to return a 1, and if num isn't 0, we have to do this other thing. So we can't say just evaluate it once and for all. But what we can do is separate the evaluation into the part that's just based on what I'm calling the shape of this procedure. You know, it's a list with sublists, and in there are symbols and so on. And we figure out that if it's a list that starts with if, that makes it an if special form. Do all that stuff only once, and the name for that is going to be analysis. We analyze this expression. And then later on, we do only the part of the evaluation that requires knowing the value of num. Or saying that another way, we do only the part of evaluation that requires having an environment. So what I'm going to do is essentially this. We're not actually going to use the piece of code that I'm about to write, but I think seeing it will help you understand. I'm going to say define evaluate expression in an environment. Now, here's where we take advantage of the fact that we're using Scheme, which has first-class procedures, as our implementation language. Because I'm going to call analyze of just the expression. So analyze does the analysis part, the part that we can do without knowing the value of num. In other words, without an environment. The result of calling analyze is going to be a procedure, not a metacircular procedure, but an STK procedure that embodies what it is we have to do once we have an environment. So in order to do the evaluation, I can find my yellow chalk, which I conveniently left 2 boards away, and say, call that procedure with the environment as an argument. Okay? So the reason we're not really going to do it like this is, first of all, if we made an analyze procedure and just immediately called it, that eliminates the purpose of this analysis, which is to remember the result of the analysis. So we're going to have to store that result from analyze someplace so that every time we call this procedure, it'll be available to us. And the other thing is they happen at different times. So it's rare, although it does happen, that namely when you type in an expression at the scheme prompt, then we are going to do that. We're going to evaluate, we're going to analyze the expression and immediately call the analysis procedure, because the expressions you type at the scheme prompt, we don't have to remember the analysis. It's just a one-shot. You type it, you get a value, you move on. It's the ones that are the bodies of procedures that we have to really remember. Okay? So analyze takes a metacircular expression as its argument, and it's going to return an STK procedure, which we can then, at our leisure, call once we know the environment. All right, so let me nope, wrong one. There we go. That's my problem. Analyze that scum. So here's the thing that I just wrote on the board. MC eval just calls analyze and then calls the result of that procedure. Let's look at analyze exp. This is the thing that has the form of what used to be eval, but now it doesn't take an environment as an argument anymore, because what it's going to return is an STK procedure that takes an environment as an argument. So let's start with an easy case. What if it's self-evaluating? If the expression is self-evaluating, we call analyze self-evaluating, which is right down here at the bottom of the screen. And what it returns is, this is an STK lambda, remember. Lambda of environment, ignore the environment and return exp. So here we're taking advantage of Scheme's lexical scope, because this exp is the argument to analyze self-evaluating. When we call the analysis procedure, the thing that's created by this lambda, it's not going to be from inside analyze self-evaluating. But nevertheless, this lambda, whoops, this, in, looking for in. Oops, no, I'm not. I don't know what I'm doing wrong, but anyway, doesn't matter. This lambda expression remembers the environment in which it was created, namely the call to analyze self-evaluating, and so it remembers the value of exp. So if we're looking at that 1, for example, we would do analyze self-evaluating of 1, and this looks like a step backwards. Things are getting more complicated. Instead of just returning 1, we're returning lambda of environment 1, basically, ignoring the environment that we're given. So you have to remember the distinction between STK environments, which are implicit in this. So when you see that symbol exp, that symbol is looked up by STK in an STK environment. this env here, this argument, is a metacircular environment. As far as STK is concerned, it's just a list structure. But it's the kind of environment that the evaluator creates. Okay? Analyze quoted. Analyze quoted does something a little bit interesting. It has this let expression. So why does it do that? Why doesn't it just say define analyze quoted exp to be lambda of env text of quotation, which means catter, exp. So this would look like the thing that we did just above it for analyze self-evaluating. What does this let buy us? And it isn't very much that it buys us in this case, but looking at the simple cases will prepare you for the more interesting cases that are coming up. What this let buys you is that we only have to pull out the catter of the expression once. If we did it the way I wrote behind me on the board here, every time we eval this quoted expression, we would have to take catter of it. We would have quote foo, and we would pull out the foo from the quote foo. This way, we pull out the foo from the quote foo just once, and the analysis procedure is effectively lambda of, well, down here, up there, lambda of env foo. Okay? So this qval, that's not a metacircular variable. It's an STK variable. So everything in STK is faster than doing things in the metacircular evaluator because we don't have to evaluate, we don't have to interpret STK the way we interpret metacircular scheme. It's done for us. So the let takes the catter out of execution time and puts it into analysis time. And analysis time only happens once, and execution time happens potentially many times. So that's a slight advantage, which is going to turn into a bigger advantage when we're doing more complicated things. Any questions yet? I understand this is new, and the examples don't look very interesting so far. But anybody, any confusions I should clear up? Okay, moving on. Okay. Oops. Right, here's something a little more interesting. Analyze assignment. So the expression we're looking at is setbang variable value expression. Okay? So as in the case of quote, we have this let. The let happens when you call analyze assignment, not when you are actually running the assignment. So this let only happens once. And we have two things. var is assignment variable of exp, which is catter of exp. Car of exp is the word setbang. Catter exp is the variable that we're assigning a new value to, the metacircular variable that is getting a new value. And now comes the interesting part, right here. Assignment value is cateter. So it's the third piece of the setbang expression. But we're not just saying let vproc be assignment value exp. We're saying let vproc be analyze assignment value exp. Okay? So if you say setbang foo, big, long, complicated expression, that big, long, complicated expression gets analyzed as part of analyzing the setbang. And therefore, we only have to analyze it once. when we actually call the analysis procedure, which is this lambda of n thing, we're going to set variable value, the same as in the regular metacircular evaluator, var, that's the variable name, to vproc of n. So call vproc with the current environment, which will be different each time. So imagine that this setbang is part of a procedure body, and we call the procedure over and over again, so we're doing this setbang over and over again with different values for things. So calling vproc with the environment will give us a different value each time, right? And then we set this variable to that value in the current environment. Okay? So I want, again, the really, whoops, I'm going the wrong way. The really important part of this is this call to analyze right here. So analyzing an expression involves analyzing all the sub-expressions. So you'll see in a moment when we look at if, that when we analyze this particular if right here, we're going to analyze also equal num0. We're going to analyze 1, not very hard. We're going to analyze times num fact minus num1, which includes analyzing asterisk and num and the call to fact and the looking up of fact and the minus and so on. All of that stuff is part of the analysis of the if. Okay? All right, let's look at analyze if. It's coming up pretty quickly here. Here it is. So given an if expression, we pull out the three pieces, the predicate, the consequent, the alternative, and we analyze all of them. So that's what I just said. We analyze equal num0. We analyze 1. We analyze times num fact minus num1. Okay? Once we've done that, we can make the analysis procedure, the thing that's returned by analyze if. And remember what the one in the metacircular evaluator looks like. There are three calls to MC eval. It says if true, MC eval of if predicate of if env, then MC eval of if consequent blah blah blah, else MC eval of if alternative blah blah blah. Instead of that, we say if true, pproc of env. So we've already analyzed the equal num0, and we just call its analysis procedure with an expression that has a value for num. And then we call either cproc or aproc, but not both. Okay, now somebody should have a question. By now there should be questions, unless you're all completely lost. Yeah? Does it mean that every time you would be calling eval before, you use analyze instead? No. You only do the analyze once for this expression. Oh, yes, that's right. Every place, pretty much every place in the metacircular evaluator code that used to say MC eval is now going to have an analyze, and then depending on circumstances, it might or might not run the analysis procedure or some analysis procedure. Yeah? Okay, why does it say true question mark? That's really something that was already in the vanilla metacircular evaluator. And the reason is they're leaving open the possibility that we might, in some variant evaluator, use a different representation for true or false than STK does. For instance, we could have a scheme variant in which number sign t is true and anything other than number sign t is false, so kind of the opposite of what scheme does. We would implement that by changing true question mark. Okay? That's why. Yeah? Ah, okay. So this defeats, you think, the special formness of if. Yeah. He's saying, well, remember, if is a special form, has to be a special form because in in the case of a recursive procedure like this, we want to make sure that we don't keep calling fact for num equals 0, num equals -1, num equals -2 on forever. But analyzing this expression doesn't involve calling fact. It just involves registering the fact that this is a procedure call. And that comes running the procedure, we have to look up fact in the environment and call that procedure. So it's OK to analyze both branches, even though it wouldn't be OK to run them. Good question. Thank you for asking that. OK, I have 5 minutes left before we do course evaluation. So let me proceed to the really crucial part of this, which is right here. What happens when we see a lambda expression? Well, we pull out the formal parameters from the lambda, call that vars, and then we take the body of the expression. And remember, the body of a lambda can be more than one expression if you're doing non-functional programming. So we have this thing, analyze sequence, which does just what you think it does. It takes a list of expressions, analyzes all of them, and returns a list of analysis procedures. OK? Do I mean that? No. It returns one analysis procedure that consists of recursively or evaluating each piece of the list. So analyze sequence makes an analysis procedure for the body. And then we call make procedure. In the regular metacircular evaluator, this would be make procedure, lambda parameters of exp, lambda body of exp, env. But this time, what we remember in our abstract data type procedure is the analyzed body. This is where the speed saving comes from. Because when you create a procedure, that's when we analyze its body. And what we store, we don't store the text of the procedure at all. All we store in our data structure is the analyzed procedure body. Get it? And so it's when we say define fact that we do the analysis. When we say fact 5, that analysis has already been done. Now, we do have to analyze the expression fact 5 itself that you type at the command line. But the actual procedure body, including the recursive calls to fact, that's already been analyzed. And that really speeds up the process of doing a recursive call. So that's something that you're going to play with, I guess, in the lab. But no, you're not. But you can play with it in the lab if you feel like it at your leisure. So try hard not to get confused about the difference between an STK procedure, which we haven't changed at all, and a metacircular procedure, which is the thing that this is all about. That's the first sort of summary point. And the second summary point, I said at the beginning that what we're doing is writing a compiler. Mostly when you think of compilers, they compile into machine language. But that's not always true these days. So if you write a Java program, often the Java compiler doesn't compile into machine language. It compiles into this intermediate thing called Java Virtual Machine, JVM code. And the point of that is that the JVM code is runnable on everybody's computer, not just yours. Well, this is kind of like that. It's compiling metacircular scheme expressions into SVM, Scheme Virtual Machine code, otherwise known as STK procedures. Okay? So compiling scheme into scheme really does give us a speed payoff. And I'm actually not lying when I say that this is like what a compiler does. This is a compiler for scheme. Now, because we're compiling scheme into scheme, it leaves out a lot of the stupid, boring details in grown-up compilers, which you'll get more than you want to know when you take 164, which you should do anyway. It's mostly interesting, despite the stupid, boring details of machine language. So this is your introduction to the concept of compilers. Whew. OK, HKN people. Great. So what's going to happen, these guys are going to give you evaluation forms to fill out. One for me and one for your TA, is that right? Yeah. Only once on the form that's for me, you're going to take one of these Post-its and you're going to write on it, Post-it, your name, Frank Bubar, and your login, your class login, CS61A-XY, whatever it is. You're going to write these extremely legibly. Capital letters would be fine if that makes it more legible. If your name is very long, I only need a substring of it. What we enter in is the login, and the name is just, it tells me, do you want to enter the score for this person? And we check to make sure it's the right person. So the reason for Post-its is that the course evaluation you're going to do is anonymous. So you don't put your name or anything on the course evaluation form. You stick a Post-it on it because you want a point for doing this. These guys, after they collect your forms, are going to pull off all the Post-its and give them to me. But they're going to keep the form. So I don't get to see your form before the end of the semester, and I never get to see your form with your name attached. Okay? But I do get your name so that I can give you the point. Okay? Oh, and you're going to have two forms to fill out, one for me, one for the TA. Only put on one Post-it on one form. Okay?